Assalamu alaikum everyone, Badshah is here, and today in this video I'm going to discuss the database management system. So what is database management system? When we talk about database management system, then first term which comes to our mind is data. Actually, data is a raw facts. We can say that everything which is storable, which we can store in the computer, is called data. It may be text, it may be photos, okay, it may be videos, it may be numbers, etc. So everything which is storable is called data, where database is a collection of related data. For example, a database of videos, database of photos, okay, database of text, etc. Information processed data is called information. The data after processing is called information. For example, when you give to the computer 2 plus 2, then 2 plus and 2 is data, and computer process it and give you the result 4, then 4 is called information. Database management system is a software. It is a program which is used by the computer, which is used by the users to do some type of retrieval, manipulations, and to produce some particular information. Actually, a database management system is an application. It is a central layer between the user and the actual database. Characteristic of the database is that we'll discuss. Actually, the data are usually the real world entities. Their relationship are builds, and uh, and also that isolation of data and applications. It isolates the data and its applications, and due to the database management system, its redundancy decreases, its consistency increase. We can use different type of query language to manipulate different data. We can view the different views, multiple views. For example, the user views, the administrator views, and the most important thing is that it provides security to the data. So the user of the database management system are the designers. Designers are actually those engineers, these software engineers, the database engineers, who build the database, who implied the constraint on it. And the administrator are those people who actually administrated the database. They don't know how the database was designed. They actually know how to run the database, okay. And the administrator also don't have the deep knowledge about the database designing and its maintenance. And the end users are the users who actually use the database management system, okay. For example, when you check your roll number from any university database or from the board database, you don't know how the database is maintained, how it is created, and how it is administrated. You just know how to put your roll number and how to get the data. Architecture of the database management system is that the first one is the data layer, the application layer, and the user presentation layer. The database layer discusses the physical layer, where the data is actually stored on the hard disk, okay. How the data is stored on the hard disk, this is discussed in the database layer. Application tier, this discusses the applications and the applications which are used to manipulate data on the physical hard drive, and how to get from data, and how to make changes, and how to retrieve the data. Presentation layer actually discuss the software which is used to show the data to the users, okay, how the data is presented to the users. Database models actually discuss the connection of database, how the data and its entities are connected with each others, and how the data will be processed, how it is kept in the hard disk in the database, and its different views are discussed in data models. Most important data models in the database management system is the hierarchical database. Hierarchical, it uses the tree structure. To store and manipulate data. Network data model, it is just like a graph, okay. And entity relationship, it takes a real type of entity. For example, the student, department, these are the real world entities, and they have different type of characteristics, properties. For example, the student have properties of its roll number, its name, and its subject, etc. And the relational model actually discuss the table in which data is stored in the table format, okay. Hierarchical data model organize data into a tree-like structure, where each record has a single parent or root node. Sibling records are stored in a particular order, okay. So it is just like a tree-like structure. For example, college further have its departments and its infrastructures, and a department may have the courses, the teachers, and the students, and course may be of theory and the lab. So you can see that here data is organized just like a tree data structure. Network data model builds on the hierarchical model by following many-to-many relationship. So it's usually just like a graphs which are connected with each other, as you can see in this graph. The most important is, which are usually discussed, the entity relationship model. In the entity relationship model, the daily life entities are taken and their relationship are built with each other. For example, this is the student entity, and or you can say this is the employee entity, and this entity is department, okay. Actually, when the SRS are given, then all the nouns are taken as an entity and the verbs are taken as the relationship. For example, empty works it department. So the entities, this shows the attributes of the entity. For example, the name of the employee, the number of the employee, okay, the post held by the employee, and the department entity may have the name of the department, okay, and the name of the department and the number, etc. Okay, there may be different type of attributes which may be used. The second one is the relational database. Actually, it's a relational data model. In the relational data model, we discuss the same entity attributes and relationship, but the entity is converted into the table format. For example, this is a table format for any employee, for example, okay, and the employee attributes are converted into the columns. For example, the student ID, the student age, the student class, and the student section, okay. Data is divided, as we just discussed the entity relationship model, where data was present just like a pictorial, which was a pictorial representation of data, and pictorially data was connected with each other, and there was no exactly data was put into the pictorial representation. But here now in the relational model, you can see the data are put it in the relational into the tables. The schema of the database are discuss the skeleton of the structure, how the database is stored in the computer. For example, this shows the logical structure which is shown to us. This shows the physical structure. So the physical structure, the physical schema discuss how data is stored on the hard disk, how data is stored on any storage devices, and this discuss how data is shown to the human beings. Okay, you can see that data is organized, different views are created to show the data to the different type of employees are the human beings. Okay, so this was the basic introduction of database, that what is database, what are their models and the schemas, etc. Assalamu alaikum everyone, Afzal Badshah is here, and today in this video I'm going to discuss the entity relationship model. When we discuss the entity relationship model, we usually discuss the conceptual view of the database. Okay, and the entities are usually the real world entity. We take it from the real world. Okay, for example, student, teacher, department, etc. Usually when the SRS, when the software engineering department get information from any company to build any database or any software, they usually concentrate on the on the nouns and the verbs. The nouns are usually called the entity, and the verbs are usually called the relationship, the association. For example, I can say the employee works in department. Then you can see that the works is actually the association, and the department and the employee are the entity. So entity represent the real world object. For example, it may be a student which can study in any department, is a teacher which can teach in any department, and any project on which some engineer works. Okay, so what are the attributes? Attributes are the characteristic or the properties of any entity. For example, student may have its name, its roll number, and its date of birth. And for example, if we discuss the employee, then employee will also have its name. Okay, it will also have its date of birth, it will also have its registration, it will also have its pay. Okay, so the every entity has its own characteristics and the properties which are used to build any relation, to build any table, is called the attributes. The different type of the attributes are, and in them the one is the simple attribute. Atomic values cannot be divided. So the any attribute whose value is atomic, whose value is simple, and which cannot be divided further is called a simple attribute. For example, the registration number, it is also a primary key, but it is also a simple attribute which cannot be divided further. And if there is any age, then we can't divide the age further. Okay, composite attributes are those more than one sample. Okay, in composite attributes we usually store more than one value. For example, in the name we will store the first name. Okay, also we will store the middle name. Okay, also we will store the last name. Okay? So the name is a composite attribute because it has more than one values. Derived attributes are those attributes which usually don't exist in the physical database. These are not stored in the database, but it is derived from any other database. Usually we don't store age in a database, and the age is derived from date of birth. Age is derived from the database. For example, the years of service are usually not stored the duration of the service is usually not stored in the database, but it is derived from the date of joining. Single value attribute, the attribute which has only one value. Okay. Multi-value attributes are those who may have more than one value. For example, the phone number. Any person may have more than one phone numbers, and also the address. One person may have different addresses, the different cities' addresses. Here the one entity relationship is showed. The entity is the student, and the student has different type of attribute. For example, one is the name, and the name is actually a composite attribute which has more than one values. And birth date is a single value attribute, and age is a derived attribute which is derived from the date of birth. Roll number is a simple or atomic value, and the phone number is a multi-value because we can store more than one phone numbers in one column, in one phone number column. So what is key? We usually use key in it may be a collection of attributes, it may be a single attribute from the set of attributes. For example, the student have different type of attributes, the name, the registration number, the date of birth, etc. We must take one number, one attribute from his characteristic which may separately identify it in a database. For example, we take any university student data, then we can categorize the student by their registration number. And if we take the citizen data, then we characterize the every citizen of the city of the country by their national identity card number, by their national registration number. So the super key is actually a key or a combination of key which may be used. It may be a one attribute or a combination of more than one attribute which may be used to separately identify the data. Okay. And the candidate keys in the super key, actually in the super key we take the minimal super key. It is also, it may be a single attribute, it may be a combination of attribute which may be used to identify the data uniquely. Okay. And from the candidate key there may be a different type of candidates key, but we take only the powerful key among the candidate key which may be used by the database designer, which is selected by the database designer to use it as a. So the primary key is selected by the designer of the database to uniquely identify the data. For example, in the university, the student may have their registration number, the student may have their CNIC number, okay, the student may have their roll number. In the department, the designer take the roll number as their primary key, although they may use their registration number, their CNIC number, but according to the requirement, they use only the roll number. So they select the roll number as their primary key. So it depends on the situation, it depends on the designer, and they view the situation, and according to that they select the primary key among the candidate keys. Relationship. As I discussed earlier, this relationship discuss the associations of different entities. When the engineers get requirement from any company or any organizations, they concentrate on nouns and verbs. Okay, actually the people who don't have detail about the software engineering, they don't know how to separate the entities and how to associate them with each other. but the database engineer concentrate on the nouns and the verbs. And the nouns, for example, here in this employee works in department, here the employee is a noun, so it will be an entity, and department is a noun, it is also an entity. But you can see that works is a verb, so it will be an association. A relationship set, a set of relationship of similar type is called a relationship set. When similar type of relationship is built between the entities. And degree of relationship discuss the number of instances who are going to take part in the relationship. It may be a binary, it may be a ternary, it may be n-ary, etc. It is a one-to-one relationship, okay, and here is the, for example, entity 1, which is A, and here is the entity 2, which is a B, and you can see that every instance of A is making relation with any one instance of B. Okay, we may take example of student. For example, this is student, and we take example of project. We can say that only one student will work on any one project, and only one project will be assigned to any particular student. One-to-many relationship. In one-to-many relationship, you can see that here the one instance of the entity A is going to make relationship with two instances. Okay, it's going to make relationship with two instances of the B, which is called the one-to-many relationship. We can take example of a teacher and subject. Okay, one teacher can teach many subjects. Okay, one teacher can teach many subjects. He can teach networks, he can teach the OOPS, he can teach a database, but every subject is assigned to only one teacher. Many-to-many relationship. Many-to-one relationship. Here you can see that these instances are making relationship with only one instance of the entity B, and we can take example of employee. Okay, and we can take example of department. Many employees work at one department. Okay, many employees work at one department. In many-to-many relationships, you can see that two or many instances are going to make relationship with the one instance, or here from B the two instances are going to relationship with one or with many. So we can say this is a many-to-many relationship. Many instances can have a relationship with the second one, and from the second they may have relationship with the first entity. And we can take example of students. Okay, we can make example of student. We may take example of subject. One student may study more than one subject. Okay, and one subject is assigned to more than one students. Relationships will be total participations and the partial participations. When all the instances of the entity take parts in the relationship is called total participations, and if few instances of the entity are going to take part in the relationship is called a partial relationship. Generalization discusses the general entity. For example, if we take the employee and we take the student, okay, and for example we can take the driver, etc. Specialization discuss the general entity type. For example, the person specialization in the specialization person, and we can take person as a student, we can take person as a teacher. So the teacher and the student and the teacher is the spatial type of person. And in inheritance, the person characteristics, their properties are taken by the child entities. For example, the person is a general entity and the student is a specialized entity. Here the person may have the name, age and gender, but these all the characteristics, all the properties, attributes of the person are copied by the student. We just add the new entity, the new attribute as a roll number, because we cannot assign the roll number to every person, because if the person is a teacher, then he may have the employer ID. If he is a citizen, then he may have a national ID card number. Okay, that was for today about entity relationship models. Thank you so much. Assalamu alaikum everyone, I am Afzal and today I am going to discuss the relational model in database management system. In this video, I will discuss the relational models, the relational algebra which are applied under relational model to store or to get or to manipulate some data. I will also discuss some type of relational models, and I will also discuss some SQL structures, some queries which we may apply on the data structure. When we talk about the relation, it means that we are actually talking about tables, that our data is actually stored in tables. Relational model means that our data is stored in tables. Okay. In relational data model, relations are saved in format of the tables, as such like that. Okay. Data is stored just like that. For example, if we are creating a table from the students, then the table name will be student and it will have some attributes. For example, the column name, which is the roll number, which is the name and phone number, etc. So the only one row in the table is called tuple. For example, we have stored the data of 100 students, but the data of only one student of Mr. A, his roll number, his name, his class, etc. Its detailed data from the column, from the table, is called a tuple. Relational instance actually define the set of tuples which exist in any particular relation, in any particular table. And when we discuss the relational schema means that we are actually discussing the name of the table. We are also discussing the attributes of the table. Okay, when we discuss the name and attributes of the table, then this is called the relational schema. Relational key is you can say that this is a primary key which is used by the database engineer to identify any particular tuple, any particular row in the table or in the relations. Attribute domains describe the some predefined value scope of the domain. For example, if in the address, for example, we have the country, and in the country we have set domain that we can select only 3 countries. For example, we may select Pakistan, we may select Saudi Arabia, we may select Turkey, etc. So this is called the attribute domain. Relational integrity constraint discuss the constraints, the restrictions, the rules which we may apply on the relation. The first one is the key constraint. This discuss the constraints which are applied on the key and you may say on the primary key, which is used to uniquely identify our tuple. For example, we may say in every relation or in every table that the primary key must not be null. Okay, the primary key must not be null. The someone is domain constraint, as I just told you, that we put some constraint on the domain of some attributes. That, for example, we may put constraint on the age, that the for example, you are going towards the Nadra, where the citizens are registered, then only those person can get their registration card whose age is above 18. So this will be the domain constraints. Referential integrity constraints are associated on the relationship, that the constraints which are applied between the entity relationship is called the referential integrity constraints. Relational algebra actually discuss the algebra mathematical terms which are applied on the tables, on the relations, to populate data, to show the data to the users, to the admins, etc. It is a language. It is a language to show the different type of queries which we apply on the tables. The first one is the select query. For example, you can say that here some thing is selected from the table books. Okay, sorry, from the books table, where the subject is a database and price is equal to 450. The project have different type of constraint. For example, here they are selecting something from the books, but they may constrain here on the subject and the author, and according to that the data is populated. Union combine two tables data. For example, here the data is combined from the book table relation and from the articles relations. Set different is also the algebraical term where the author who has written books but not included from the table article of the same author. Okay, it is just like a difference. You have studied that A difference B. Okay, constraint product show the books and articles of the author. Okay, and rename if you want to change some relationship, then we may apply these relational algebra on the different type of relations. Here model to relational model, here the relations model discuss the table and relational model discuss how data is represented. Actually, here we are mapping entity. We are showing the pictorial representation of an entity. And pictorial representation, you can see that this is a student. Student may have different type of attribute. For example, the roll number, his name, his class, and subject, etc. But you can see that the roll number is underlined. The roll number underline is showing that actually it is a key. Okay, it is a primary key which is used to uniquely identify any particular student, any particular tuple, any particular row from the table student. Here you can see that the relationship is shown in a pictorial formation. You can say this is the student. Okay, and student have its own attributes, name and roll number, etc. And the roll number is showing that the roll number is the primary key of the student. We will use the roll number attribute to populate data from the student. And the second entity is the course. The second entity is the course. It has its course ID and title. This course ID is not underlined, but here in this pictorial format, the course ID will be its primary key. and the diamond sign shows that it has the relation. The student has relationship with course, and the relationship is enrollment. That student is enrolled for any particular course. So the association also have its own attributes that it discuss the marks of any particular student in that course, and it also discuss the joining date of the student in that particular course. Here you can see that the weak entity set are discussed. When we discuss the weak entity, then it means that weak entity is such like entity which doesn't have any primary key, which can be uh, whose attributes may be, whose tuples may be identified uniquely. So you here we assume that the dependent entity is weak. It doesn't have any key attribute to determine its attributes. And here you can see this is the student, and you also can see the student has roll number. The roll number is its key. We can use the student roll number to determine its name and its other attributes. So student is not a weak entity, but here in this position you can see that this is the dependent. The dependent key entity is also showed with double line. Okay, as you can see that this entity is also showed with double line, and the double line with the double line you also can see that it has only name, and there is no other attribute which may use to determine to populate its data uniquely. So it is a weak entity. So this showed the dependent sign that this dependent entity actually depends on the student. Here the hierarchical entity mapping is shown here. For example, we are going to hire a hierarchical to show the hierarchical position. When we go to show inheritance in programming or in the database, for example, here the person is shown. Here the person is, for example, here the person is shown. Okay, so the person has its attributes name. It also has age. Okay, it also has age. It also has its gender, age, and name. These are the attributes of the person. And the student and teacher is its specialization. Student and teacher is the specialized form of a person. So every student, when these are inherited from the person, it means that every attribute of the person are also inherited. So we add only the roll number to the students, and it also means that the students also having the name, the student is also having the age, student is also having the gender, because it is all the attributes of the person has been inherited. And the same things with the teacher, that it have its own employee ID, and all the other data, for example name, for example the age, and the gender is inherited from the specialized entity, which is a person. Structure query language, we use the structure query language to create databases, to create a relation, the tables, and to insert some data. So the create database code to create, when we create any database or any tables, we use the create. And if you want to delete some database or any table, then we use the drop. And if you are going to change some data in the database, then we use the alter keyword. Data manipulation language may contain different type of commands. Select from where. We use the select to select data from particular table. For example, we can say select where id is equal to 100. We have to select those person whose id is equal to 100. From where we have to select. This shows that we have to from table is equal to employee. Table is equal to employee where. Okay, this will be written here. Okay, select from table. Okay, select name from table is equal to, for example, employee, where id is equal to 100, and we want to insert data. Then we may write insert into table, and we give the values of the exact tables, and update and delete also. These are also used to manipulate the data. As you can see that how the data is selected. Select author name. We are going to select the author name from book author. Okay, where age is greater than 50. We have to select the author name from the table book author, and the author, those authors whose age are 50, and we insert into table. Here we will write the table where we are going to insert the data, and what values we are going to insert will be written here. And if here we are going to update the table book, where the column, the attribute author is B, and where we have to change the author to E. So okay, this was little about the relational data model, the algebra which is used to represent different type of operations on the table and the databases, and also the structured query language which is used to change or to manipulate the data. Okay, thank you so much for watching. Assalamu alaikum everyone, I'm Afzal Badshah, and today in this video I'm going to discuss the database normalization, and also I will discuss in this video the dependencies, how the attributes depends on each other, and also the anomalies. For example, if we want to update data in any database, but we update data in one location but we don't update the data in another location. This happens due to the non-normalization, and if the data is scattered and it is not well engineered during creating the database. Data normalization, this is usually done to avoid the dependencies, and also to avoid the anomalies. And we will also discuss the different type of joins to gather data, to categorize data, or to collect data from different type of tables. When we depend dependencies, the functional dependency means when any attribute functionally depend on any other attribute. For example, here the x is functionally depending on y, or we can say that y is determined by the x. So the x is called the determinant because it is going to determine y, and y is called the dependent. And in example, you can say that, for example, we are talking about any student, then the name and addresses and his birth is determined by the registration number. So registration is determined, and all the other attributes are called the dependent. In the trivial functional dependency, it means that if x determines y, where y is the subset of x, it means that all the instance of y will be within the x, because x is the subset of y is the subset of x. All the instances of y are within the x. Non-trivial dependencies holds when y is not the subset of x. It means that the sum of its elements will be there in the x, but not all the elements will be there in the x. And the next one is the complete non-trivial dependency. This means that we take the intersection of x and y, then its result will be null, will be 0. This means that there is no common attribute, no common instances between x and y, which will be called the completely non-trivial dependencies. Anomalies means that some type of mishandling, you can say some type of mishandling, some type of errors, some type of mistakes in database. The first one is the update anomalies. Actually, the anomalies occur due to the if the data is scattered, if the database is not well organized and it is not well engineered, then such type of anomalies occurs. For example, the update anomalies, we having the student data in 3 different locations, but we update the data in 2 places but not in the third place, then this will be called the update anomalies. And such like the delete anomalies, we delete the data from one place but not delete it from the second, third or any other position, then this is called the delete anomalies. And the next one is the insert anomalies. It is the same such like the update and delete anomalies, that we insert the data in the one table in one location but we don't copy it into the other location where the data is present, then this will be called the insert anomalies. So how we can remove these anomalies, how we can remove the dependencies between the data? To remove the dependencies and to remove the anomalies, the normalization is used. Okay, the fourth type of normalizations which we are going to discuss in detail in this video are the first normal form, the second normal form, the third normal form, and also the bytecode normal form. So what is first normal form? In the first normal form contains non-atomic value. For example, in our relations we are going to store data, but one cell contain more than one values. We can say that when we put more than one names in the one tuple, as you can see that the course is an attribute, the content is also an attribute, then you can say that in the programming contents contain more than one value. It contains the Java, it contains C++. And also in the web you can see that it contains the HTML, it contains the PHP and also the ASP. Then you can see here that the table contain more than one value in only one tuple, which is the repetition, or you can see these values are not atomic. Then you can see after coming into the first normal form. First normal form means to remove the repetition of the values, to do all the values in the atomic. For example, programming may contain Java, programming may C++, web may contain the HTML, web may contain the PHP, or web may contain the ASP. So this is now easy to search it, because every value, every cell, every tuple have unique value as, or sorry, single value. What is the second normal form? Second normal form discuss the functional dependencies. Here you can see that the student ID is determines student name, okay, but the project name is determined by the project ID, and project ID may be determined by the student ID. So we can determine the student name, project name by the student ID, but we can see that these are partially dependent on the student ID, because the student name depends on the student ID and project name depend on the project ID. So to enter into the second normal form, the first condition is that you must be in first normal form, and secondly there should be no partial dependency. So how we can remove the partial dependency? We may break this table into 2 tables, as you can see. Now the student contain the student ID, student name and project ID, where the project ID, here you can see that it becomes the primary key for any project and also the foreign key in the student ID. In the third normal form, transitive dependency exists in the third number form. As you can see, that student ID determine the zip ID and zip ID determine the city. Okay, it is just like a situation that X determined Y and Y determined Z. It is just like such a situation, so it is not allowed in the third normal form. So the condition for the third normal form is that your table must be in the second normal form, and also there should be no transitive dependency in your tables. So we can remove it by creating a second table, and you can see that the transitive dependency is removed here. Okay, the transitive dependency is removed here because student ID determine the Y, the student name, and also determine the zip ID, and here in the second table zip is determining the city. By coded normal form, it is actually the extension of the third normal form, and the one condition is that, for example, X is determined A, then X must be super key. Okay, X must be super key. You have already studied about, we have already discussed in our previous videos that the super key is any key or the combination of key which may be used to determine the other attributes. So if X is going to determine the A, then X must be super key. Okay, for example, in this condition you can say that student ID is a super key, and in this condition you can say that the zip ID is a super key. Different types of joins in the database management system or joins are actually used to get data from different relations, from different tables, or to combine different type of data from different type of table into one table. So the joins are the inner joins. Okay, these are the inner joins and also the outer joins. The first one is inner join, which is the theta join. Theta join applies different type of condition onto tables. These condition may be greater than or equal to or less than or equal to. And for example, this is for example one table with us, which is mobile, and these attributes are the mobile model and the mobile prices. We have the second table with the name laptop, and the attributes of the laptop is the model and also the price. Okay, and now we are going to apply the conditions that we should show all those data from the table A and B, from the table mobile and laptop, where mobile prices are lower than the laptop prices. As you can see that the first one, this assets prices is lower than from the asset. Okay, so you can see after showing the result of the theta, all these results are populated from the both tables where the prices of the mobile is low from the laptop prices. The second one is the equigen. Equigen equally get the data from the both of the tables and the equality operator. It shows all the data. For example, we have the one table with courses. Okay, the courses ID, the course, and also the department of the course. Okay, database is the CS department, and mechanics is the mechanical, and it is electrical engineering course. Okay, now we have the second table where the computer science department HOD is A, Mr. A, and the mechanical engineering department HOD is Mr. B, and electrical engineering HOD is Mr. C. So how we can combine this by using the equigen, that you can see that all the data is populated and showed here that the CS department HOD is A, The HUD data is taken from the second table. Mechanical engineering HUD is Mr. B, and electrical engineering HUD is Mr. C. The natural gen, it gets the data from the both table and any particular common attributes. For example, here is the employment. One table implies one table, and the second table is the department, and the common attribute is the department name and also the department name. So this is the common attribute between the table A and table B. So the natural gen of this will be that all the data related to the first one, all the department names are shown here in the front of the first tables. Okay, so the outer gens are the one is the left outer gen. It actually take the data from the second table, from the right table according to the left table. We have one table which is with the name of country, and it has some data, and the second table is the state. Okay, for example, India, and India country ID is 1, as you can see that is the 1 and 1, and the state are Karnataka and Tamil Nadu, etc. For Pakistan 2, and Pakistan is also Islamabad, but you can see that Nepal country ID is not listed here. But the left gen will get the data according to the left table. Okay, so all the data related to the left table will be shown, but it will not consider the second one. It will just get the data for the left table. As you can see that in this table it combines the data from the both table, and table takes the data from the first, and according to that the data is shown here. Okay, and for those values are null here in the state, but because the Nepal was listed in the left table, so this value is listed here too. And if we take it as a right gen, then Nepal will not be enlisted here, because Nepal is in the left country, in the left table. In the right genning, all the data from the right table which matches with the left one will be shown. In the right gen, for example, you can say this is the same table, and this is the same table of the state, and here you can see that Nepal is not listed here because it is not in the first table. But the Bangladesh, and Bangladesh is listed in the second table on the right table, so Bangladesh is also listed here, but the Nepal is not listed here. In the first example, in the left, you can you notice that the Nepal was listed but Bangladesh was not listed, because this example was the left gen and this is the right gen. Full gen will combine the data from the both table, and for example, Bangladesh is here, but Bangladesh is not listed here, so it will also be taken. Nepal is shown here, but Nepal is not shown here in the state table. But because we are going to use the full gen, so the data will from the both table will be shown here. As you can see, the data from the both tables are taken and shown here on the third table. So this was all about the normalizations, the different type of joins, etc. Okay, thank you so much for watching.